All right, so I want to show you a memory trick on converting in between logarithms and exponential. When we do this, it does have to be set up in this specific way. So when I have a log base b of, let's say, e equals f, or when I go from the exponential, b to the g equals h. And I'm just making them different letters so that we know these are two different tricks. These work independently. So when we go from a log to an exponential function, again, it has to be in this form. I have to equal f. The log part has to be on the left side. So one visual trick I like to use is if I start with my b, I go through the f, and then I come back to the e, and look at that! It makes an e for exponential. So that helps me when I'm transitioning. So I go to that b, and then the next thing that I do is the f, and then the next thing that I do is the e. And then the next one, from going through exponential into log, I'm going to start with a capital L here, go through the H, make that G, and then, oops, I didn't know it could do that. And then, essentially, you're making a block L letter. So, with that same reasoning, I start with my B. Well, I start with my log first, but I then start with my B, and then I go to the H, and then I go to that G. And so that is just a quick visual there. Number 72. Our goal is to practice not changing into exponential form. There are going to be times when I specifically ask you, I want to see that middleman step before you give me the answer to an equation. But there are going to be other times when you want to save yourself a few minutes on a test or on homework or a space, and you just want to go straight from this into that exponential. So I'm going to walk you through a couple just of what my brain talks me through. So I think about that e. I start at the 7 to the something will equal that 49. And I know that if it's squared, that's how I get 49. Now 3 to the something gets me 81. So in my brain, I'm doing 3 times 3 is 9, times 3 is 27, times 3, 81. So 1, 2, 3, 4 3s. Now this one, a little bit different only because we have more than just a single number. I have a number with an exponent in that value there. But still my rules can be the same. I start with my 5, go through that that end value, and then get that 5 to the 7th. So I'm wondering what 5 to the what power equals 5 to the 7th? Well, without even doing any math, I know that my exponent does have to be that 7. So you could rewrite this 5 to the 7 as whatever number that ends up being, but then you would need to use a calculator. So trying to save ourselves some time, leave it as it is. All right, part D, 10 to the something equals 10 to the 1.2. Same idea as part C, so I'm going to leave that exponent in this form so that I know my outside value is 1.2. And one more. 2 to the something equals 2 to the w plus 3. Both of them have a base of 2. all I need for that outside value is that w plus 3. And I like to group anything with parentheses in these types of functions, just for safekeeping. All right, 76, we're bringing back some quadratic information. This is going to come in handy in the next chapters. So whenever we're solving quadratics, the quadratic formula is always going to work no matter what type it is, but it's not always the fastest. It's not the most efficient. There's quite a bit of room for human error. So the other types that we can use for most efficient, seeing if there's a greatest common factor, and difference of squares, we could also try and undo the problem versus getting it into that full exponential form like this guy here. So for A, I'm going to use what it says here, that outthink the problem. So since I have x squared, I know that my first term in each parenthesis is going to be just that x. And then I know that this times this has to equal -8, but then they both also have to add up to that +7. So I know that 8 times 1 is 8, and if that 1 is negative, that would get me a +7. And there we go, equals 0. And so now I can easily solve that zero product property. I get x equals 1, x equals -8. Now for B, I'm going to do that undo problem. So I could expand this, right? It's the exact same of x plus 2 times itself, but I am going to instead undo that outer square, right? It's the only thing on that left side. It's the outermost thing on the left side. So I can undo a square. But whenever we undo a square, we do have to remember that I get both a positive answer and a negative answer. And since it's a quadratic, just a reminder that you will have those two answers. So all right, and then I'm going to have you guys try on your own parts C and D. So see if any of these guys would work, or if you can kind of hack it just by talking yourself through it in your head, because I know those blocks and diamonds take up quite a bit of space.